to the Evolution Library. Today, we'll be going into depth of natural selection with the experts. CEO of DAR Labs, Dr. Winters. Nice to meet you.
Nice to meet you, Dr. Foley.
All right.
My great friend Jacob, how you been doing today?
I'm doing great. What have you been reading?
I just been catching up on my notes of natural selection and the origins of it.
Oh, really? Fill me in on what you found.
Me and my research partner Nick, we have been studying this, and we have been traveling the country in search to find examples of natural selection. And if you would like, I can take you to his office.
Absolutely.
Paul, sorry. This is Dr. Apple, Dr. Winters. This is my great friend, Dr. Foley.
Nice to meet you, Dr. Apple.
Dr. Foley, pleasure to meet you.
Sorry about that. Before anything, would you like a beverage?
Yes, sir.
Would you like a beverage?
Yes, sir.
While I go get your beverage, can you start filling him in on the research we done?
Yes, sir.
Thank you. Appreciate
All
it.
right. Fill me in on what you found, Dr. Apple.
Well, I think before we can even get into my study of single gene traits, we gotta talk about the father of evolution,
Fill me in.
Charles Darwin. You know, Charles Darwin, fun facts about him, he was born on the same day as Abraham Lincoln.
Interesting.
Yes, sir. So his journey on evolution first began on the HMS Beagle, the ship that took him to South America. There, he discovered single gene traits. Now, single gene traits is when a trait is controlled by one single gene. Examples of this, for humans at least, attached earlobes, you know, tongue rolling.
Oh, sorry about this.
Thank you, sir.
Thank you.
Thank you, boss.
Oh, hold on. Before we do this, still toast.
Yes.
Okay.
A toast.
Evolution.
Thor Labs.
Our labs.
Continue.
Well, evolution of single gene traits, can lead into allele frequencies, which, when it comes to animals, a group of animals can...
Let's go. Let's go check.
You might laugh for no reason.
Let's go.
This is our writer, Dr. Slade.
Hello, Mr. Winters.
This is our visitor, Dr.
Hello,
Foley.
Mr. Foley. Nice to meet you, Dr. Slade.
See, I've taken my bills today. Just saying.
Well, good for you.
I have been studying polygenetic traits.
Come on, man. We got a big body. Hurry up. Snap the ball. Come on. Get ready.
Please, our CEO is here. Just
Hey.
calm down. Play the game later.
Are you serious, bro? Is this guy serious?
Who are you?
That's our boss. That's the CEO. You're acting like you don't have proper etiquette when someone comes in the room.
It's okay. It's a fun rule, but he's taking it a little bit too far. I handle him after this.
Continue what you were saying.
Sorry about
A
that.
polygenetic trait is a trait that's controlled by a group of non-allelic genes. A polygenetic trait is also controlled by two or more genes, usually by different genes at different locations on different chromosomes. An example is that humans can be different sizes and have different eye color.
So, do you have any more information?
Sorry to cut you off, but it's kind of loud in here. You got like disrespectful people in here. Yeah. So let's take this to my office. You take.
Doctors?
What were we talking about?
I ended off on polygenic traits.
Oh yes. I got you. I'll add up to that. Well, in addition to studying the different types of traits of evolution, we have been assigned to different types of selection inside of natural selection. I'll start this discussion by talking about directional selection. Do you guys know what that is? I got you. Directional selection is extreme phenotyping is favored over the other phenotypes, causing the allele frequency to shift over time in the direction of that phenotype.
I know on to what Dr. Winters has been studying. I've been studying stabilized selection, which is a natural selection in which population stabilizes on a particular non-extreme value. An example of this for humans is birth weight. This takes a while to over time to occur because the more immediate form looks and more becomes like the more common population, while the less extreme become, relatively out of the population. So we have this so that the common offspring become more like the common population.
Adding on to what Dr. Winters and Dr. Epple have been saying, my assignment was disruptive selection, also known as diversifying selection. It describes changes in a population genetics in which extreme values for a trait are favored over.
So I see you guys have been really busy.
Sorry, I have family member shit I think about.
Sorry about it.
Okay. However, I think you guys have forgotten to mention the principles of natural selection: variation, inheritance, population growth, the survival and reproduction.
Why don't you explain those to us some more?
Well, the variation of species has an effect on natural selection. The same type of animal can have different traits and benefits from the others. That can cause a better chance for an animal to survive the elements and continue to live longer. Also, the inheritance of traits passed on through ancestors helps future generations.
I can add on to that with population growth. Now, in population growth, there will be natural disasters. While that is quite sad, it's a fact of life. The ones that are the strongest can adapt and survive and pass on, like bacteria. Darwin explained this when he traveled to the Galapagos Islands and wrote his book, Origins of Species.
Yeah, I can add that to that too. Yeah, it's my great friend. I don't know how to say that, but yeah, it's okay. But with the population growth, there's also been reproduction, which also means they have been I'm sorry about that, surviving more. So I want to touch up on survival and reproduction. It's basically the ones who survive get to pass down their DNA. You may be asking, why survival and reproduction? Why is that important to natural selection? Do you guys know why? Yeah. It's important because without no reproduction, there will be nothing. No animals, no insects, no humans, and no natural selection. Reproduction creates the generations. That creates individuals that compete against each other. That the ones that are more natural, more successful, sorry about that, will survive and pass down their DNA.
Is that all for you?
That would be all for me for right now.
Well, on top of that, Jacob, Dr. Cole, there's so much more out there on natural selection. So me and Isaiah have decided that starting next month we're going to travel around the world and to research more about Darwin's journey, because natural selection is so fascinating and we just want to know more answers.
I want to cut you off for a sec. This is not natural. It's delicious. It's actually artificial.
Alrighty, well, you heard it from the experts at Dar Labs. It was a pleasure meeting you both.
Yes, sir. Well,
Alrighty, well,
have a good evening.
good evening.
Have a good evening.